All right, so having done the Desmos activity, we should have an idea about what to expect from this. Like here I've given you a basic equation, y equals 2 to the power of x. Based on that activity, you should already know they're going to be looking at something that does something like that. But if I ask you to make this graph on your paper and actually make it precisely, do you know whether it goes like that, or whether it goes like this, or whether it goes like this? Do you know exactly where it's going yet? No. And for some of you, you caught that because you were playing with that number here, and you were seeing what it did. Others of you, you could tell kind of what it did, but not necessarily in the detail. So that's what we're going to take a look at here, is that little detail about what was happening. Now, when we first start making graphs, one of the ways that we often do it is we make a table of values. If I did this for that, taking each of these x values and plugging them in for x up here in the original equation, this is what I would calculate for each of these values. So, for instance, like 2 to the power of 3 equals 8. We can actually calculate each of these. And notice some of them give us decimals. And so I want you to notice a couple patterns in this table. And I'm going to start by looking at the whole numbers because they're easier to process, but the same ones will be true, as you'll see in the decimals. If I go from 1 to 2, 2 to 4, 4 to 8, what am I doing to each of those numbers to go to the next one down?
Multiplying by 2.
Yeah, we're multiplying them by 2. So every time I'm going downward, I'm multiplying it by 2. If I do 0.125 times 2, do I get 0.25? Yes. And so the same pattern is working up there. But now, what if I weren't going that way? What if instead I were starting at the 8 and I were moving up? So 8 to 4, 4 to 2, 2 to 1. What am I doing as I go up this list? We're what? It's not subtracting. We're dividing, yeah. Because if going down the list is multiplying by 2, moving up the list is dividing by 2.
Because 8 divided by 8.
Which actually shows us something rather interesting here. Because notice this value right here. 2 to the power of 0. Notice it equals 1. A lot of people have trouble understanding, why would it equal 1? And there's lots of different ways we can explain it, but this is just one more way that you can see it. Because notice if I just follow this pattern, the next thing in that pattern would have to be 2 divided by 2 is 1. And notice that fits with the rest, because 1 divided by 2 is a half, or 0.5. And notice that same thing happens. Now, if I plot these points and look at the graph, we can see how this happens visually. Now, this is called an exponential function here. This is actually the parent function. For this type, anytime you have a number to the power of x, we call that exponential. So 3 to the power of x, that's exponential. 4 to the power of x, that's exponential. Even crazier stuff like 1/2 to the power of x, that's also exponential. Anything to the power of x is exponential. But in this case, it's 2 to the power of x, right? Remember in our table, it doubled our values. Look at the graph here. Like let's say I start here at 1. It then goes to 2. It then goes to 4. It then goes to 8. What am I doing to my points as I'm moving to the right? I'm doubling the height. Remember in the table I doubled that y value? Here in my graph, that means I'm doubling the height, because of course y is how far up we go. And so we're doubling the height each time. So like if I know this one's at 8, how high would I have to go next time? 16. And after that, I'd have to go up 32, then 64. I'm just doubling it every time I go to the right. Well, what about when I go to the left? I start up 1, then I go to a half, and then a fourth, and then an eighth. As I move to the left, what am I doing to the last value that I had? Well, if I go to the right and I'm multiplying by 2, to the left I'm dividing by 2. Just like in the table, when we were moving upwards, I divided it by 2. It's the same pattern. It's just a matter of if you think you're going to the right or thinking to the right. Think right or left. It's always multiplying or dividing by 2. Now, why is it 2? Because this number is 2 right here. So every time it's 2 to the power of x, that means double. Or divide by 2 as you wish. Now, a little bit of detail in here. What is happening over here? As this graph keeps going over here to the left, what is happening to this graph? Well, does it ever drop down like into here? Doesn't look like it. Well, this value out here, that's a really small decimal, right? If I take that really small decimal and divide it by 2, I'm going to get another small decimal. If I take that small decimal and divide it by 2, I'm going to get a small decimal. Notice, as I go to the left, I keep getting smaller and smaller decimals. Am I ever going to get 0? No. It's always going to be some really small decimal. Now, it might be so small that it looks a lot like 0, but it technically still is not actually 0 yet. And so this graph is kind of weird like that, right? Compared to what we've done before, for the first time we have it approaching 0, but never actually touching it. This actually has a fancy mathematical term. That line that it's approaching is called an asymptote. Please go ahead and write this part down. This is the one thing I definitely do want you to write down to your notes, because otherwise later on we're going to be talking about an asymptote, and you're going to be saying, what is it? I want you to be able to look back and see. Now, in the graph that we started with for today, that graph had an asymptote in it. We got to get specific, though. A couple of details about asymptotes. One, we do draw them on our graphs. Now, you'll notice on this particular graph, I drew it in as a dotted line. We always draw our asymptote as a dotted line. A dotted line means we're using this as a guide. It's a piece on the graph that I can show, but it's not actually my graph. It's just a guide that I'm using. But also, we write the equation of that. Now notice the equation of this line right here, y equals 0. Anytime you have a horizontal line, it's going to be y equals some number. And our asymptotes for these exponentials will always be horizontal lines. So it'll always be y equals some number. Now, on our parent functions, that number is always 0. But you're going to see here that we can change where that asymptote is. And so that's something I'm going to want to take a look at here. So we're going to take a look at then, how do I tweak that kind of equation? And then how do I tweak the graph? So we're looking at y equals 2 to the power of x minus 1. So it's the same thing, but we got a minus 1 in there. Based on the work you were doing earlier, what's that minus 1 going to do to our graph? Well, the minus 1, it's hanging on the end, right? It's not up in the exponent. So it's not affecting the x, it's affecting the y. So this minus 1, it's going to be moving it down 1. Now, the little detail-y things then, I'm actually saying that it's shifting down 1. My parent function is y equals 2 to the x. Notice my parent function is the same one as I just graphed earlier. So my graph is going to be the same, except it's all going to be shifted down 1. Notice, though, that that moves my asymptote. Because if my asymptote is normally here at 0, and I move everything in the graph down, the asymptote moves with it. So when you go and make these graphs, the very first step to making an exponential graph is that you draw the asymptote in there. And remember, draw it as a dotted line, because it's a guide for our graph. It's not the actual graph itself. Yes, that matters. Once you've drawn the asymptote, then we can start plotting our points. Now, there's one point that you need to know. Just one point that you need to know. And that is, what's anything to the power of 0? 1. Remember, anything to the power of 0 is 1. And so that means that our first point that we plot is 1 above the asymptote. Now notice, it's all relative to the asymptote here. It's not relative to the x-axis. Once I draw in that asymptote, it's like I don't even notice the x-axis anymore. I don't care about the x-axis anymore. All I care about is where is the asymptote, because everything is relative to that. And when I say everything is relative to it, I mean everything. So that first graph we made, we went up 1, and then we doubled our height, right? Where am I going to be counting from? The asymptote. So if I just went up 1, I next go up 2 from the asymptote. And then if I double that height, 4 from the asymptote, notice. And then if I double that 4, I get 8. But again, I'm counting from the asymptote. Every single time I'm counting from the asymptote. How do I know it's doubling? Because it's 2 to the x. And that's where we're going to be focusing our attention when we start graphing these. There's going to be a lot of 2 to the x's, but as you saw earlier, we can change it, and it's going to have some effect on the graph. All right, and when we go to the right, I'm multiplying by 2. So what do I do as I go to the left? Divide. We divide our heights by 2. And so I put a few points over there. Always put a few points on each side. Once we've drawn those points in, then you can go ahead and draw your curve. So that's our basic process about how we do it.